Today, we're going to be talking about Moore's Law and energy innovation. This is Energy Matters with Claire and
Dan.
All right, this is going to be a fun, juicy one. Tell me what you want to talk about with Moore's Law today, Dan.
No question. So first we should define our terms.
Yep.
So Moore's Law comes from Gordon Moore's observation in the 1960s and early 70s, where he noted on a technical basis that the number of processing units on a computer chip doubles or gets twice as dense about every 18 months. And if you flip that around, it means the computing power goes up. And as the price of those processors goes down, what we observe and what we call it in the world of energy systems is the learning curve. And very broadly, what that means is that what we observe phenomenologically or observationally is that the price of energy systems like solar panels and wind turbines, but also things out of the energy world like Bic pens, calculator, whatever else, they drop in price by about 20% every time you double the number of widgets that are both manufactured and sold. And all of that's important in this learning or cost decline curve. And for the true nerds like me in the audience, this is called a power law. And we'll get back to those later. But the idea stemming from Moore's original observation, we're getting more and more efficient, better and better at computing. And there is a world of discussion about, is this how we can quantify and track innovation? Is Moore's Law ongoing forever, or will it come to an end? And the death of Moore's Law has been forecast many times over. And like Mark Twain said, reports of my death are greatly exaggerated.
I love that. So one of my favorite examples of Moore's Law, as probably not surprisingly, is how PV modules, photovoltaic modules, and their pricing have consistently outgrown their expectations. So every single year that we have predicted how low solar costs will end up being and how many solar installations will be installed, we have underestimated grossly. There's a great article in The Economist, which we will put on our website, energymatters.world, that goes through installations that have been, always been more than 3 times higher than their 5-year forecast. And I love that statistic.
And I think that's so critically important because it's not just that this has persisted for years. So the Moore's Law, the learning curve for solar panels is the most famous. And everyone who gives a talk about energy shows a version of this.
From the International Energy Agency.
That's right. So pardon me for describing a graph, which is probably, a
no-no in the
dangerous thing to do.
world.
But thinking about it, what it says is that if you look at the price of a solar panel versus not time, but versus the number of solar panels that get deployed, what we see is a steady fall in prices. And what we normally do is we plot this in power law or log space. And it's a straight line. And it's been a straight line downward to lower prices since the 1970s. And so if we just put that in context, solar power back in the 70s, when really the only installations were on Skylab and some remote locations, it was $50 per watt or more. Today, 2025, solar is as low as 50 cents per kilowatt hour. So it's fallen.
Cheaper.
I'm just trying to get a sort of a benchmark. So prices have fallen dramatically, orders of magnitude, and I think that the current record, but Claire is going to hopefully correct it, is that the cheapest solar project I've seen today is a large-scale project in the desert of Dubai, and the all-in price, the solar panel, the installation, the land, the everything else, came in at something like 60 cents for everything per watt generated.
Yeah, that's hard to beat. Though I will say at Sunrock Distributed Generation, where we're financing solar installations, I was just pricing a project that was at $1.98 in Maryland.
Yeah, so these are amazing numbers when you
Yeah.
think how great the solar installation is in the middle of the Dubai desert versus here. But the broader point about these learning curves or these experience curves is that it's not just a function of doing the research and development. It's also a function of getting the product into different modules or built into solar panels that are building integrated on rooftops or low-cost arrays in your backyard or in some big system. And that's a function of the policy environment, the learning, what are the barriers to put it in place. And so this is not a law like E equals MC squared. It's not a basic law of physics. It's a observational, or what we call in the physics world, phenomenological. We observe it out there and we explain it after the fact. But what it means is that we have so many decades of its experience working, and we'll talk about when it doesn't work, hint, hint, systems that you can't mass produce and then mass deploy.
Yep.
But if you can count on it, which we've done for decades in solar panels, electric vehicles, wind turbines, what it means is that if you do what economists call forward price or subsidize when the technology is new and expensive. Remember, when you've only deployed a few solar panels or a few electric vehicles, it's easy to double the number out there.
Right.
It's not so easy when you're way
mass commercial
down
scale.
the
Yeah.
curve. But
Yep.
what it means, though, is that well-placed and ideally temporary subsidies in the beginning can do a great deal to drop the price for everyone.
As an example, so when I started Sun Edison, we were getting a self-generation incentive program, or SGIP rebate, of $4.50 back in 2005, and we were selling projects for $9 a watt. At this point in 2025, you would be a fool to spend, more than somewhere between $230 and $250 a watt for an installation pretty much all over the country. Of course, it depends on labor costs and wage rates and, et cetera, and whether it's a carport or ground mount. But, we're seeing prices anywhere from $1.80 to $4 a watt, depending on how complicated projects are.
Yeah, and I'd mentioned this record project in the Middle East, where admittedly they got the land at some incredibly low cost because it's desert of basically 60 cents for all in. But what it says to our thinking is that anyone who wants to forecast where energy prices could go needs to really look hard at these learning curves. And so what Claire highlighted is from the regular reporting by the International Energy Agency in Paris, where she worked at one point. What we observe is that utility executives, people in different fields, are consistently underestimating how powerful this law is. And the forecasts year after year don't do justice to the actual cost declines and the actual increase in the amount of these technologies being sold.
Right.
You can use that in your models, in your business case forecasts, in whatever else, to say, if we keep building the market as the U.S. was doing and may or may not be stalling now, but China and others are doing really strongly, you can then influence the continuation of this so the prices will fall as a function of what you do. And so there's a virtuous or a positive feedback cycle of taking advantage of Moore's law, getting more technology in the field, seeing low prices as a result, and then using that to continue the process.
Right. The only caveat I would add to Moore's law is regulatory uncertainty, right? So if you change laws, which is happening every day these days, then things can get out of whack. And it's not just on the federal level, it's also on the state level. You might look at the Massachusetts Smart 3.0 program, which is changing how things are going. In the state of Maine, they're retroactively changing some of the rules. So you might be in construction on a project and the rules are changing. So, that on the technology perspective, Dan, I totally agree with you with Moore's law, but then, people come in and muck everything up.
And just to highlight how, Claire said the amazing word, there are some of these changes regulatory in nature that are retroactive or what I would say punitive. And so Nevada may take the cake for a place that enabled solar because there were federal subsidies and programs out there. And then after the fact, the Nevada Public Utilities Commission that regulates this decided they wanted to claw back those benefits that had already been given out to homeowners that put solar on the roof. So that goes way beyond kind of regulatory confusion. That's just outright hostility to the new leading edge or the clean energy leader. That is gross.
Which makes me sad. So let's get back to Moore's law and technology, right? So I think one of, another point is energy efficiency. Between 2010 and 2018, global data processed by data centers rose by a factor of 6, but energy usage only increased by about 6%. But let's talk about data centers for a second, because and this is a question back to you, is Moore's law hurting us because there's new massive energy demand from data centers and AI and crypto mining? Is that making things worse for the climate?
So there's both a direct answer, and my direct answer is going to be no, it's actually making things better. But let me back up, because this idea that as you make something cheaper, you do more and more of it has a long history. It goes back to something called Jevons paradox. It was something that came out of the 1780s in England, where people forecast that because England was getting better and better at mining coal, the prices would fall, so people would use more of it. And we have a current version, which I would say has been totally debunked, but I think there's still probably some holdouts out there, that used to claim there was a so-called rebound effect against energy efficiency, where if you made energy cheaper, people used more of it, and this was a negative spiral. And I would argue that the analytics have said that these kind of innovation pessimists, or whatever you want to call them, were wrong. I think they would still say they weren't, but I think the data shows that we actually don't want to just use things for its own sake. So, for example, if we make driving cheaper by moving to electric vehicles, doesn't mean that we will spend our whole lives in the car.
Right.
We might spend our whole lives in the car because of traffic, but we don't spend our whole lives in the car because the price of driving has dropped. And that is kind of this perverse look at learning curves. So this question that you asked is a little more focused than that.
I think, for sure. But I think there's a lot of discussion about AI right now and the Jevons paradox and what AI is going to do to all of that.
Yeah. So I guess, there's no single answer, and we will be doing multiple episodes, you can be sure, on AI and data centers and machine learning. But I think that the simplest version from my look at the data today is that whatever worries or benefits or upsides you have around AI usage, and I have a friend I just talked to yesterday who said he talks to ChatGPT so much that he has renamed it Chat. And when he hasn't been on for a while, Chat asks him, is something going on? Are you okay in your life? Why aren't you talking to me regularly?
Yeah.
So leaving aside
the
kind of the spooky aspect of it, I would say that just like calculators in the 1970s, when teachers said, well, because kids use calculators, their math skills will deteriorate, and other kind of technology crises, if we use AI to enable productivity and not to replace our thinking, then we actually want to use more and more energy because we want to do more AI and machine learning based projects. And because of Moore's law, with the falling price of clean energy, that's actually a wonderful issue, because if we can do what people in the field call electrify everything, move not only from a home that's partially electric and partially gas to an all-electric house, add solar panels, switch our driving, battery storage, switch our driving from petroleum cars into electric vehicles, that's part of this electrify all. And because it is true today, thanks to Moore's law and the learning curve, that it's now cheaper to build with new money a clean energy power plant than it is to operate an existing fossil plant. Electrifying all and greening all will push us down the learning curve and will benefit everything, including the use of AI. So I view AI as a good, steady customer for clean energy, not some worry.
Yep. Another question, which I hear from my dad and naysayers, of which I put my dad in that, is the
Thank you,
rapid
Dad.
is the rapid obsolescence or e-waste cycle. How does Moore's law factor in that?
Oh, boy. So
I know that's a tough one, but the question is, can you recycle solar panels?
Yeah.
Yes, you can. What are we going to do
can.
with all these wind turbines, when they're obsolete?
So there's so many aspects, and you who do the business side of this should really be answering your own question.
I know.
But I would say one feature is that the lifetime of a solar panel is somewhere between 25 and 40 years. So their lifetimes are long. And while humans are not very good at recycling today because of laziness and lack of policies, I'm actually going to predict that 10 years from now, the fastest growing new research institutes and the new departments that will be launched at colleges of engineering around the world will be on recycling, upscaling, reusing materials, because we could be building almost everything to make the process of disassembly and recycling easier and easier. And
Absolutely.
we've been very, very
lax
on doing so. But even if we weren't good at it, solar panels last multiple decades, wind turbines last a couple decades, and these are all high-value materials that if we're even halfway intelligent, we can build markets in to recycle. And let me give you one example that goes totally under the radar screen. Anyone who bought a laptop or a cell phone in California almost certainly unwittingly paid a roughly $14 cost per cell phone and about a $29 cost per laptop. You didn't notice it, nothing changed in your behavior, but those monies go into a process to assist companies to recycle. And should we be doing this for everything? Yes. Should the cost be higher? Probably also yes. But this was put in place based on some ideas that BMW and others launched initially when they said, we can't guarantee that every physical atom in every vehicle that we make will be recycled. But if we use 100 tons of platinum, we commit to recycling 100 tons of platinum from the international market. Now, whether you think this is actually something devious where they are making a commitment that looks good and they're just buying it up and other people have to deal with the problem is a fair complaint. But the idea that each ton of material that is used by a company or by a person is going to get recycled through an active policy like this, that's not so hard to envision we would do it across the whole economy.
Absolutely. Yeah. I want to get back to a point about, which I often hear again from naysayers of, well,
you have a lot of naysayer friends, I have to say.
I sure do. I sure do. And family. Yeah. But, the argument that like, oh, I shouldn't install solar right now because I'm going to wait until the technology gets better. Or, oh, I'm not going to, buy a new refrigerator until the technology gets better. That seems like such a lame argument to me because, for example, in 2008, Grow Solar, thank you, Jeff Wolf, if you're listening, installed 8 evergreen solar modules on my roof, which were, I think, 180 watts. And that's, a silly size right now. And I paid $11 a watt for that installation. If I had waited, sure, I would have better modules on my roof right now, but I wouldn't have saved a third of my energy costs every year for the last, 15 years if I just waited.
And you wouldn't have contributed to the learning curve by being an earlier adopter that
right.
then helped the prices go down. So I think for this one, we have to go to that high-end source, and that is the Peanuts cartoons. And in that, Lucy talks about Arbor Day, and what she highlights, first of all, she thought Arbor Day was Harbor Day, so she went down to the docks, and that didn't pan out well for her. But what she did discover was that the best day to plant a tree was 20 years ago, and the second best day to plant a tree is today. And that fits into this learning curve mentality, but it also says that if a new product gives you better services, and notice that things that are purchased, there's already this inherent issue that we're making the process of buying solar for your roof easy if you own a roof, and if you are a renter, low income, it's much harder. So there is a justice inequality aspect in this story that a few policies have tried to address, but not many. That's a diversion for now. We'll come back to it. But the issue here is really, if you can get the benefit of that service, even at a slightly higher cost, you and all other customers will benefit by moving down the learning curve. Now, there are cases as an early adopter in the process. Now, there are example technologies where learning curves don't hold. And one should be upfront about them because in some ways the exception defines the rule. So we observe strong learning behavior in modular technologies where the so-called just-in-time delivery of parts, where the market can be amenable to uptake it, where the companies can grow to put it in place. All of that contributes positively to these learning curves, meaning lower and lower and lower prices. Where we don't see learning is also instructive. Technologies that are already fully mature, or technologies where you can't mass produce, like building aircraft carriers or, interestingly and controversially, nuclear power plants, we see prices rising over time. Now, nuclear proponents are going to raise a flag right away and say, wait a second, that's due to regulatory issues or risk perception, whatever else. But the basic numbers, whether you're pro or against solar or nuclear or aircraft carriers or whatever else, is that we observe this data very clearly. Things that can be standardized and mass produced and mass distributed exhibit learning behavior, and things that are more one-off and unique for whatever reason we don't observe this behavior.
Though you would think with nuclear there would be more modular design. So I think in the last how many years we've only installed one nuclear power plant, and the cost overruns were just extraordinary.
That's right. So we'll be talking a whole episode, many episodes, but one coming up very soon about nuclear. And actually my lab just published a paper comparing the costs of nuclear in the United States, where we have about 100 nuclear plants, France, where there's about 58, and China, where there's around 25, but more than half of all new nuclear plants all worldwide that are planned to be built in the next decade are going to be built in China. So what we observe is that the cost of nuclear in the U.S. across different plant designs and different manufacturers, the cost has risen steadily to make it vastly more expensive today than installing the same amount of renewables plus storage. France also shows cost increases, although not quite as bad as the U.S.
Well, and to interrupt you for just a minute, 75% of France is powered with nuclear.
And the prices are rising, which is why France is diversifying into wind and solar.
Right. Versus Germany, which has always done a lot of solar.
And of course, Germany is interesting because, like California, they have both said, and that's the fourth and the fifth largest economies in the world. They have said, we won't do any more nuclear because of risk and waste issues, although they both cheat. Both California, that imports nuclear power from the Four Corners area of the Southwest, nuclear by wire, and France sells nuclear to Germany.
Right.
So Germany doesn't have the plants, but they have the benefit of those nuclear electrons. And so both places cheat, but they're able to say they're nuclear free.
Yep. And back to Germany for just a second. They were an early adopter of the feed-in tariffs and all of the concepts behind making solar cost effective.
Yeah. And I think that's a really critical story because in Germany, Hermann Scheer, who was essentially the architect of the solar revolution that made the pricing of solar super not only cheap, but also simple. And the way it worked in a feed-in tariff in the early model, it's evolved in the many countries that have adopted it since, was that the earlier that you commit to putting solar on your roof in a given period of time, say a 1-year block of solar deployment, you get a 20-year commitment for the utility to buy your energy at a fixed price.
Yep.
And that price was often quite generous, sometimes too generous.
Sometimes too generous, yeah.
And that led to learning in Moore's Law because there was a known set market.
Yep.
And as we have evolved and developed a model that was adopted by all the utilities in the United States. It's not clear where things are going
not
now.
all of them.
Not all.
But for example, the Massachusetts SMART program, the Solar Massachusetts Renewable Target Program, that is a feed-in tariff.
Right. But places like California have had this other model, which is an RPS, a renewable portfolio standard. That percentage requirement meant the utilities had to install at minimum a certain amount of these technologies. No one knew exactly what punishment would happen if they didn't get it. When New Jersey punished its utility for not making its target, they used the fine to then install solar streetlights, so they got some more solar into the system. So there are some interesting little side stories, but all of these are part of a feedback process where installing more of the technology that makes your cell phone cheaper, that makes your laptop cheaper, goes into this process of making the product cheaper over time. And we literally rely on this in utility planning, in energy planning, over and over again.
So we at Energy Matters are a fact-based entity, but I want to ask you, Dan, about some predictions to close this out. What do you think, what technology or concept that in which Moore's Law is applied is going to be the most valuable for reducing climate change?
So I'm going to say something that I think 99% of our audience will disagree with.
As you do.
As I tend to do. So my forecast is that in the year 2070, which I unfortunately do not think I'm going to get to experience, I think the world will be 70% powered by fusion, and fusion has zero market share today. But I think that 70% of our energy mix in the year 2070 is going to be half terrestrial fusion, meaning plants we don't have today. We only have one working fusion system in Livermore, California. But the other half of that, so 35% of our total energy, I think is going to be solar, because solar is fusion 93 million miles away, meaning the sun.
Right.
So I am banking on Moore's Law to keep the cost declines going for solar. And from the first fusion plants that are vastly expensive because they're just research facilities, I think starting in about a decade and a quarter from now, we're going to start to see fusion plants being deployed on the grid as pilots. But by 2070, we will have discovered that using the universe's most abundant element, hydrogen, and some heavier hydrogen, deuterium, we are going to see fusion take off, because fusion is not only a source of energy that we can do in power plants, but fusion has another killer application, to go back to our startup episode, and that is moving us around the solar system.
Yep. I love it. I love it. And don't mess with this guy. In 1992, he predicted that Miami would be underwater in 2050. And that prediction's going to be true.
I wish it wouldn't be true, but I fear we're on a path for that. So we have raced through the learning curve, or we've raced down the learning curve. We're going to come back to it a number of times. But this is Energy Matters with Dan
and Claire.
And you can follow us and you can interact both via the website, energymatters.world, or you can go to the email address and send us your comments, critical, non-critical, new topics, etc. And that's info@energymatters.world.
Thanks for listening.